example you can take it as, for example, one generating station is located and it travels over 60 kilometers to reach some substations, let us take, okay, in such case. So you can see here, so this is generating station and this is a transformer. So after generating station, it is connected to a transformer and it is traveling. So first one feeder is available, it is connected to one substation, and B is connected to another substation, C is connected to another substation, D is connected to another substation. Let us take now 4 substations are available and E is also one substation, okay. So first A substation, it is 2 seconds. So you can see there is an 5 seconds decrease in each when there is an increase in the distance. So 2 seconds, 1.5, 1 and 0.5. So you see here, this is operating time. So when the operating time gets increases, so distance gets, so you can say that when the distance gets increases, the operating time gets decreases, okay. So in this scheme, the overcurrent protection, the time discrimination is incorporated, okay. Here time only it is incorporated. We doesn't matter how much amount of voltage or current or something it is flowing, we are considering here only the time, okay. In other words, time setting of relay is so created that in the event of the smallest possible part of system is isolated. Next is radial feeder. So already you know what are the different types of feeders available. So first I'm going to deal with the radial feeder. So so these are the 3 feeders: radial feeders, parallel feeders, ring feeders. So these are the 3 types of feeders available. So first we are going to deal with the radial feeder. So in this radial feeder, let us take this as a radial feeder itself. So the single line, you can take it as a radial feeder. The main characteristics of radial, so now how many of you connected? 19, 18 of you connected, okay. The main characteristics of radial feeder is that power can flow only in one direction. You can take same, it is possible to flow in only one direction, and from generator or the supply, from generating stations to the supply substations, for example, okay. So it has a disadvantage that, for example, here if there is an any problem occurs at the B point, if any problem occurs at the B point, suddenly if this relay is operated, if the circuit breaker is open, then after that C and D will not be getting any supply. So A only at a B it will be stopped, okay. So after that you will not be having the continuity of the supply. Then after the time graded production of a radial system can be achieved by 2. One is definite time relay, another one is a inverse time relay. So definite time relay is you will be having a fixed time. You will be having a fixed time and it will be operating with a fixed time. That is called as a definite time. So time of operation of each relay is fixed and it is independent of operating current. Does not depend upon how much amount of current it is flowing. So it may be any amount of current, any amps of current flowing. It doesn't matter. It depends only on the time. And thus the relay can be an operating time of the same. You can take the same examples, okay. What is the disadvantage of the system is if there are a number of feeders is series, you can see third point, the tripping time of fault near the supply end becomes high. So disadvantage can be overcome to a reasonable extent by the inverse time delays. Next we are going to see what is inverse time delay. Here inverse time delay just opposite to that of the definite time delay. Here it does not depend upon it does not have a fixed time. It would be depending upon the amount of a current which is flowing. So if you're having more amount of a current flowing means, if you're having more amount of a fault current means, the time second for the tripping will be less. So that is called as an inverse time delay, okay. So inversely time will be inversed according to the amount of current. That is a difference. So here you can see this graph, operating time and the distance. So when the distance gets increases, so you can see that A gets decreases, B gets decreases. So when for example A and B, there is no fault, between B and C there is a fault occurs. So inverse time relay, the operating time is inversely proportional to the operating current. So with this arrangement, you are having 3 relays A, B, C with the inverse time characteristics which is shown in this figure. As I told, if a fault occurs between B and C, the breaker here it will be having the braking operation. Up to B you will be having, after the B you will not be having, C will not be having the supply, okay. So since it is inverse, you will be getting a graph like this. You will be having a graph like this. So next is parallel feeders. So parallel feeders, you can see this diagram. So this is one generating station and this is bus bar. Here, this is the substation. So one feeder, another one feeder is connected in the parallel. So what is the advantage of this? What is the disadvantage of this radial feeder is it can allow current to flow, it can allow the supply to flow in only one direction, and if any fault occurs at the middle, you cannot have a continuity of a supply. So in order to avoid that, to have a continuity of a supply, we are using the parallel feeders. So if any one of the feeder is disconnected, and another one feeder will be operating. So that is the advantage here. So protection of a system, like each feeder has a non-direction. So here another thing you have to note down is non-directional relays and directional relays. So these non-directional relays are nothing but here if you're having the double arrowhead, it is called as a non-directional relay, and if you're having a single arrowhead, it is called as the directional relay. Okay. So for example, you can consider this feeder 1 getting a fault, then feeder 1 circuit breakers will be open and the feeder 2 will be operating. Okay. So the production of system, like each feeder has a non-directional overcurrent relay. So you can see this non-directional overcurrent relay where it is connected here to the generating station. Okay. So at the substation side or at the load side, you will be having only the directional relays will be present. So each feeder has a reverse power and directional relay at the substation end. These relays should be instantaneous type and operate only when power flows in the reverse direction. So again, the connection what I've explained is given in this thing. Another one thing is also, so two types of fault may occur. One is directly from the feeder 1 via the relay A, feeder 2 via BQ, a substation and B. Like this. So directly also it may occur in this way also. Okay. Next is the ring main system. The ring main system is nothing but all the substations will be connected in a ring form. That is called as a ring main system. You can see here one generating station is there, and after that you are having the substation 1, substation 2, substation 3 and 4. Between, you can see these non-directional relays are connected only at the generating side, and the remaining all sides you will be connected only with the directional relays. As I explained earlier, what is directional relay and what is non-directional relay. So for example, if a fault occurs between the E and F, then only these two relays which is close to that will be operating, between which is close to E and F will be operating. Okay, so that alone will be disconnected. So but all the substations will be in connection with the supply. You will be having continuity of the supply. There will not be any breakdown. That is the main advantage of this thing. So various power stations or substations are interconnected by the alternate routes, thus forming a closed ring. In case of damage to any section of ring, the section may be disconnected for repairs, and the power will be supplied from both ends of the ring, thereby maintaining the continuity of the supply. So the same thing what I have explained will be there. Let us see this points alone. The two lines leaving, okay, this is also not needed. Yeah, so you are having the relays B, C, D, F, G, H, I will be there. So you'll be having the substations also. So you can see what is the A will be having in 2.5 seconds. Here also you will be having the degrees in 5 minutes, so 5 seconds with the each release. So you know what is pillar wire connection already. So it comes under the MESPICE circulated system, the same what you have studied for the production of alternators and the transformers. So translate scheme also you already have studied at the first unit, I think so. So MESPICE voltage balance systems. There are several differential production schemes which is used for MESPICE voltage balance system and translate schemes. So MESPICE voltage balance system. That is MESPICE circulating current system. This is MESPICE voltage balance system. Okay. So here you will be having the circuit breaker CT1 is present. Now between this, you can take this as one transmission line. Fault occurs between the in a particular transmission line. So this is at the setting end one circuit breaker. This is another in the circuit breaker. CT is connected. So as usual, primary with primary is connected, and secondary with secondary is connected. So you can see here relay is separately connected to the CT1 and the relay is separately connected to the CT2. So the pair of CT in each line is connected in series with the relay in such a way that under normal condition there will not be current flowing through the relays. Only at a fault condition a current will be flowing. Therefore under that is means there in normal condition current will be same. Here the voltages are equal in opposition, so therefore they balance each other. So you can see this is three phases supply R Y B. So similarly you are having the three transient CTs are you are having. So here three CTs are you are having. So if a fault occurs between here, so it automatically it forms a pillar wire connection. You know what is pillar wire connection. So three wires with one neutral, it will be set as a pillar wire connection, the same connection. But what is the difference between here transmission line circulating voltage balance system and circulating current system is there you will be having a common you will be having a relay connected to the